Hi teachers, this video will show you how to use the Advancing Science Kinesthesia cart for the Newton's Laws of Motion. You can see here there are two separate carts. A lower cart is the smaller one with the silver edges, the larger cart, and a block of wood. And so before the students come, you want to go ahead and stack these two carts up. It's best if you stack these up before the students come so that they start the lesson by thinking that there is just one single cart. So the larger cart stacks on top of the smaller cart, the two holes line up, and then you insert that wooden handle into the two holes there. So we will begin with Newton's first law of motion. So this first part of the activity, you're going to need your crash bear to act as the rider. And you'll place crash bear on the front of the cart, which is the section near the handle. Then you'll take that cart and you're going to roll it towards that piece of wood. Now I have the piece of wood laying parallel along the wall because I'm working in a small area. But if you have a larger area, you can go ahead and place that block of wood perpendicular to the wall, and you're going to roll the cart with crash bear on top into that block of wood. So before all of these demonstrations, of course, you want to make sure to have the students do some predicting, predict what they think, how they think the cart will move, how they think the bear will move. So you just give it a little push with your foot. That push wasn't quite enough. So I'm going to go ahead and try that again. Give it a little bit harder of a push, and there you can see the cart stops when it hits the wood and bounces backwards. However, crash bear continues his forward motion. Then you want to ask students what we can do to help make crash bear a little bit more safe. Their typical response is to give crash bear a seatbelt. Sometimes they'll say, let's tuck him underneath that wood handle, but we ask that you don't do that because it does weaken the joints on that wooden handle. So instead, use some tape, stretch a long piece of tape over and across crash bear's lap to act like a seatbelt, and then you can go ahead and repeat the experiment. Once you have him taped down, he's now attached to the cart, so he should move in the same way as the cart does. And when the cart hits the wood, crash bear will go forward just a little bit, but then he'll stay attached to the cart and move his way backwards. Now we're getting ready for our second demonstration under Newton's first law of motion. So for this one, you still want to make sure that you have just one cart. Both of our carts are stacked together using that wooden handle to keep them connected. You should practice this one before you do it with students. I practice it by just putting a piece of something heavy on the cart, but when you do this with students, you would get a student volunteer to sit there for you, cross-legged. If you look at the front of the lower cart, you'll see there's a hook there. You're going to go ahead and attach the leash to the hook. And then the next thing you want to do is make sure that your upper and your lower cart are properly aligned. And so before you do this demonstration, while you're talking to the students, getting them to make some predictions, you want to kind of pull the cart around sort of like you would a wagon, just to make sure everything is rolling smoothly. You can look at how the front cart is aligned to the bottom cart, make sure that everything is parallel. If it's not properly aligned, when you give it a tug, it won't work properly. It might hurt your shoulder a little bit there. Here is, you'll get the students sitting. They'll sit where I have that red tub. They're going to face you, and there are some metal handles they can hold on to on the side. And then you will tell them that they're going to pull out that wooden handle that you see there, but you want them to only pull it out right before you get started. If you have them pull that wooden handle out too soon, the top cart will probably roll right off the bottom cart before you have a chance to actually show them this demonstration. So you'll have them sit in place, hold on to those handles, pull the wooden handle when you are ready to get started. They'll just put that wooden handle in their lap, and then you're going to give a sharp pull on that leash. Pull out the handle, stand up, and give it a sharp pull, and you'll notice that the bottom cart comes right out. It does come out quickly, so be ready to stop that with your foot. And the student and the upper cart should stay exactly where they started. Now you can stack them back up and have the students take a closer look at this now that they know that there are two separate carts. And what they will notice is that those upper wheels are actually not touching the ground when the two carts are stacked together. So you can talk a little bit about gravity there and how well the forces of you tugging on the leash may not have impacted the student and the top cart. Gravity did impact them because they did end up coming down to the ground. You'll notice that this is a pretty active lab, so you'll want to make sure that you're wearing comfortable clothes, things like sneakers, and something that you're comfortable in moving around a lot, bending over a lot. So do think about what you're wearing when you are ready to give this lab. Now you can go ahead and set aside the leash and the handle. You don't need those any longer, or the block of wood. And we're going to move into Newton's third law of motion. I know it's a little out of order, but we like to run the first law of motion, followed by the third law of motion, followed by the second law of motion. And you'll understand why when we get to the second law of motion. It makes a much better ending for this. So for the Newton's third law of motion demonstration, you'll need 2 students, and you'll want those 2 students to be of pretty similar size to one another. And you're going to take the carts and line them up like a train. And you'll want to mark a center starting position in between those 2 carts. And you're going to always come back to that center starting position for each of these Newton's third law of motion demonstration. If you have floor tiles, you can just use the cracks in the floor tile, or you can go ahead and mark a spot with a piece of tape on the ground to use as your starting position. Now the students, your 2 student volunteers, are going to sit one on each cart facing each other. Alright, so they'll sit facing towards the center. You want them to be pretty close to the edge of the cart. And what they're going to do is push off of each other. So of course, before you get started with the demonstration, you'll want to have your students make some predictions. If student A pushes off a student B, it's usually easiest if they push off of their knees. What will happen? You'll see that both students will move in opposite directions from each other, and you can talk about the action and the reaction forces. You want to have them go ahead and just stop naturally so that you can then measure to see how far they moved from that center point. If you have floor tiles, you can just count floor tiles, or you can grab a meter stick and actually measure this distance. You should see pretty close to an equal and opposite reaction. Then you'll have the students bring their carts back to the center point, and you'll repeat the experiment, this time having student B push off of student A. And again, then you can measure how far they moved. You should see fairly similar results to the first time around. Now, you may want to have students standing on the back side of each of these just to stop them in case they get going a little too fast. Usually it's not a problem. It's actually a little tougher than it looks, and it's pretty hard for the students to get very much movement here. The next step is to then have the students push off each other at the same time. And you'll want to, of course, have the students make some predictions. How do you think this will look different if we have both students pushing at the same time? When you discuss and troubleshoot this one at the end, sometimes what happens is it's not exactly an equal reaction. Sometimes one student might move a little more than the other. And usually this has to do with the mass of the students being a little different, the mass of the carts being a little different, or even unlevel floors in your working area. Sometimes when students are explaining the last demonstration here, where both students are pushing off of each other at the same time, they'll often discuss about how they saw the difference they saw must have been due to one student pushing harder than the other student. So you'll want to take some time to discuss that, maybe draw a little diagram to show them that it shouldn't matter if one student pushes harder than the other, because each student gets an action and a reaction force, and those should all balance each other out. So any differences you see in that or any lack of an equal reaction that you see is most likely due to differences in masses, or the levelness of the floors, or maybe the wheels are working a little better in one of the carts versus the other. If you have extra time, you can go ahead and repeat this experiment with students of obviously different masses. Okay, now it is time for Newton's second law of motion. So we're going to go ahead and set aside that lower cart. We only need the upper cart. And then you'll also need the bungee cords. There should be 3 sets of bungee cords, and you're going to stretch those out and lay those parallel to one another. So those 3 sets of bungee cords will all lie parallel to one another. And you're going to put those in place behind the cart. you'll want to do this demonstration or start this demonstration near the back portion of your working area because with this one you will actually get the cart moving pretty well, so you want to make sure that you have a good amount of space to launch the cart into. So your 3 sets of bungee cords are going to lay parallel to one another, and then you're going to set the larger cart perpendicular right in front of those bungee cords. For this one, you'll use 2 different riders, one for the first demonstration, one for the second demonstration. So you'll want a rider of small mass and a rider of larger mass so that you can compare how mass impacts acceleration. So you'll have the rider sit there. It is important that they hold on to the handles for this one because if they don't, they may end up with sitting on the ground while the cart scoots out from underneath them. You'll get 6 volunteers to be your bungee cord holders. 3 will sit on each side and hold on to those bungee cords. They should sit shoulder to shoulder and then hold those bungee cords nice and tight. Now their only job is to hold those bungee cords. They're not going to actually add any extra force into those. So they're just going to hold those nice and tight. Then you'll need another volunteer, or you can do this yourself, to be the launcher. It's a tough job, so you'll need somebody strong to be able to do that. And what the launcher does is pulls the cart back against those bungee cords, sort of like a slingshot. Now, if you take a look at the back of the cart, you'll see there's these wooden blocks just above the wheels. You'll want to make sure that the bungee cords stack up against those wooden blocks and keep them away from the wheels so they don't get tangled up in the wheels. Now, when the launcher pulls the rider and the cart back into the bungee cords, they'll want to go ahead and pull that back to a certain point. And you want to mark what that point is so that this will be your force, and you want to be sure to keep the force constant between your small rider and your larger rider. So you'll want to make sure that that launcher is pulling the cart back to the same point on the floor for each of these demonstrations. So you'll go ahead and start with the smaller rider first. Pull them back against the bungee cords. There is a diagram in the lab document that will help you envision how this looks when you have all the students in place. I was doing this demonstration by myself, so I didn't have the extra helpers to hold those bungee cords for me. So when you launch the first student, they will probably move pretty far, so you want to make sure you've got plenty of space for them to get launched into, and again, you want to make sure they're holding on to those metal handles. You should put some students back into the launching area so that they're in place to stop the rider in case they might crash into a wall or the lockers or something like that. So be sure you have some folks ready to help stop, but if the rider can stop naturally, that is ideal because then you can compare their motion to the motion of the larger rider. Now, of course, Newton's second law of motion is usually presented as force equal to mass times acceleration. So to help the students understand this demonstration a little better, it's usually helpful if you could rearrange that equation so that acceleration is equal to force divided by mass. And that way you can have them think about what happens if we change the mass, which is what you're doing in this first demonstration here. You're running the smaller rider first, and then you're going to repeat having the launcher pull the cart back to the exact same point, so we're keeping the force the same, and then you'll launch your larger mass rider. We're not really measuring acceleration in this. We're actually looking at how far the riders traveled, but you can make some correlations to how that may affect if we were able to actually measure the acceleration. If time permits, you can repeat this experiment by keeping the same rider, so you would keep your mass constant, but vary your force. And you can vary the force by either pulling back the cart a little further or not quite as far, and you can see how the force impacts how far the rider travels. A few general suggestions. After each of these Newton's Law demonstrations, I recommend having the students do a little pair share. You can have them turn to the person sitting next to them and share an example of Newton's laws of motion from their everyday life. That gives you an opportunity to sort of reset your materials and prepare yourself for the next demonstration. And again, make sure that you're wearing clothing that's comfortable, you're wearing shoes that protect your feet, and as the students are working, make sure they're holding on to the handles when necessary, make sure they're keeping their fingers away from the edges of the cart and the wheels so that they're not getting pinched in this. Otherwise, it's a great demonstration. The kids really enjoy this, and I think it does a great job helping students better understand the Newton's laws of motion. So have a great time.